Hello Prep 1 students. Today we will explain the second lesson in the first unit. In the previous lesson we talked about matter and we said that all objects around us are matter. And also we talked about how can we distinguish between different matter or different objects by physical and chemical properties. But today we will talk about the structure of matter, the building unit of matter. Our lesson is matter construction. Can you tell me what is the building unit of matter? What is the most basic building block of matter? If we want to talk about the building unit, we can say that the building consists of a group of walls and each wall consists of a group of bricks. So the bricks are the building unit of building. The body of living organisms consists of a group of cells. So the cell is the building unit of the human body. What about matter? What is the building unit of matter? Matter consists of very small structural units known as molecules. So we can say that the matter consists of molecules. But what is the molecule? What is the definition of it? What is the meaning of it? We can say that it is the smallest part of matter that can exist freely and it has the properties of matter. The smallest building unit, it's a building unit, so it's the smallest part. The smallest part of matter which can exist freely and it has the properties of matter. For example, if we pour some perfume in a glass bottle and determine its mass, then open it for a period of time, or if we spray an amount of perfume, we will see that the odor of the perfume spread all over the room. And also we can see that the mass of the bottle decrease. If we open it and leave it, we will see that the mass decrease. So the particles of the perfume, which is the building unit of the perfume, spread all over the room, keeping the properties of the perfume because it had the same smell. These particles are known as molecules. We have give reason question here. When you leave the perfume bottle open, you smell it all over the room. The answer will be because the molecules of perfume are in continuous motion, because the perfume consists of smaller building unit which are molecules that are in continuous motion, keeping the properties of the perfume. And this is the first give reason today. So matter consists of smaller building units which are molecules. The molecule is the building unit that can exist freely and has the properties of matter. Then we will move to the next part, which is the properties of molecules of matter. What are the properties of the molecules of matter? The first property is the molecules of matter are in continuous motion, like the motion of the perfume particles or molecules. The second property is they have intermolecular spaces among or between the molecules of matter. There are intermolecular spaces among the molecules of matter, and there are attraction force among the molecules of matter. So we have three properties of molecules and we will study each of them and we will explain how can we see or say this property. First we will start with they are in a continuous motion. We have a small activity here in which we will put a small quantities of potassium permanganate. Potassium permanganate is a chemical compound which has a violet color. As you see, we have a bottle of water and we will add a small quantity in this bottle. Then we will leave the cylinder for a while. We will not stir or do anything. We will only put a small amount in a bottle containing water. Then we will leave it a while. We will see that the violet color of potassium permanganate spreads through the water. without stirring, without shaking, after a period of time, small period of time, we will see that all the water become a violet color or turns into violet. So we can say that the potassium or the permanganate molecules are dissociated, breaking down into particles, and these particles spread in water gradually, in all directions. So we put the drop of permanganate, and this drop of permanganate dissociate into particles and they spread in water gradually in all direction until the color of water has been changed into violet, as you see. So the violet color of permanganate spreads through all the water. And also we can have the first, or we proved the first property, which is the molecules of matter are in continuous motion. We have give reason question here. If you look at these molecules, it spread all over the water because they are in continuous motion. Give reason. A drop of ink spreads through water, or instead of ink we can say a drop of potassium permanganate spread throughout the water, because the molecules dissociated, or we can say also because the molecules of ink are in continuous motion, because the molecules of ink are in continuous motion in all the directions among water molecules. So the first property of molecules is that molecules of matter are in continuous motion. We can say that the molecules of solid matter has oscillatory or vibrational motion, while the motion of liquid is limited because there are spaces between them. In case of solid state, there are no spaces between the molecules, so their motion is oscillatory, or we can call it vibrational motion. In liquid, there is a small space between molecules, so we can say that the molecules of liquid move limited, or the motion of the molecules of liquid matter is limited, while in case of gases, they are the movement is unlimited. The movement of molecules is unlimited. Let us move to the next property. As we said that the molecules, there are intermolecular spaces among the molecules of matter. Also, we have a small experiment or activity. We will bring about 300 cubic centimeter or whatever, some or small amount of water. For example, we will bring or put 3 cubic centimeter of water in a graduated cylinder. Then we will add about 200 cubic centimeter of alcohol to the water. Of course, we can say that the sum of the volume of the product will be the sum of the volumes of the water and alcohol. So we expect that the product will be 500 because we add 300 of water, or we add 200 of alcohol to 300 of water. So the product will be 500, but that doesn't happen. We will see that the volume of mixture of water and alcohol is less. It will be less than 500. It will be less than 500. It's less than the sum of their volumes. Less than the sum of their volumes. Why? We can say that there are spaces between the water molecules. These spaces are known as intermolecular spaces, and the alcohol molecules occupy these spaces. The alcohol molecules occupy the intermolecular spaces among the water molecules. When we add water to alcohol, or when we add alcohol to water, the product will be, the volume of the mixture will be less than the sum of their volumes. It will be less than 500. So, can you tell me what is the definition of intermolecular spaces? We can say that they are the spaces that are found among the molecules of matter. So intermolecular spaces are the spaces that are found among the molecules of matter. The first property was the molecules of matter are in continuous motion, and the second property, there are intermolecular spaces among the water or among the matter molecules. Let us move to the next part. If you remember with me, the third property was there are attraction force among the molecules of matter. We have also a small activity here. Try to break an iron piece with your fingers or by hammering it. Of course, you can't break it without using a special tool. What about the water? Try to divide an amount of water in a small cup. Can you divide the water? Of course, you can easily divide an amount of water into two parts or put it in another container. So it's difficult to break a piece of iron because there are attraction force among the molecules, which is very strong in solid state. While it's easy to divide water because the force is weak in liquid state, and almost it's not found in gaseous state. So the third property is there are intermolecular attraction force or intermolecular force between the molecules of matter, which is very strong in solid state, weak in liquid state, almost not exist in gaseous state. So the intermolecular force is the force that bond the molecules of matter together. The force that bond the molecules of matters together. Give reason. It's difficult to break an iron piece with your finger because because there is a strong attraction force among the molecules of iron. Strong attraction force among the molecules of iron. If we are talking about solids, we will say that solid is a matter, and if we want to explain the properties of this matter, we can say that there is a narrow molecular spaces. If you try to find the space between the molecules of solid, it's very narrow spaces among the molecules of solid, and also very strong intermolecular force. The attraction force between the molecules is very strong. So we can say that solids have definite shape and also definite volume. Solids have definite shape and definite volume because they characterized by having a narrow intermolecular spaces and very strong intermolecular force. So the molecules are relatively fixed in their position. They are relatively fixed in their position. What about liquids? If we are talking about liquids, we can say that liquids have definite volume, but they have indefinite shape. Always liquid take the shape of the container. Why? Give reason. Liquids have indefinite shape, definite volume, because they characterized by having intermediate intermolecular spaces. There are spaces more than the spaces that found in solid state, and weak intermolecular force. Weak intermolecular force. The attraction force in liquid molecules is less than that of solid molecules. So they have definite volume, indefinite shape, and also we can say that they take the shape of the container. Liquids take the shape of the containers. Finally, gases. We can say that gases have indefinite shape and indefinite volume because they characterized by having large intermolecular spaces and very weak intermolecular force. So solids have large intermolecular force, in very narrow intermolecular spaces. Liquids liquids have intermediate intermolecular spaces and weak intermolecular force. Gases have large intermolecular spaces and very weak intermolecular force. We can say also that gases, the molecules are relatively free. We studied the three properties of molecules, and also we explained the shape and the volume of the three states of matter, which are liquid, solid, and gas. Then we will talk about the relation between the temperature of the matter and the physical state. The relation between the temperature of matter and the physical state. As we said before, that matter can change from one state to another by heating or cooling. So, what happens when the matter heated? For example, if we are talking about solid, what happens if we heat a piece of ice? We can say that when a solid substance is heated, its molecules gain thermal energy. Thermal means heat energy. By heating a solid, its molecules gain thermal or heat energy. So the speed of this molecule increase. They gain energy, so they will be very active. They will move. The speed will increase, and also this energy will make them able to overcome the intermolecular force. So the speed of molecules increase, and some of them will overcome the intermolecular force, the attraction force between them. So the intermolecular spaces will increase. They become more freely, lead to change their matter from solid state, which have more and strong intermolecular force and narrow intermolecular space, into liquid state, which have intermediate intermolecular space and weak intermolecular force. By heating, we can say that matter, when matter is heated, the molecules gain heat energy or thermal energy. Its speed increase and move more freely. The intermolecular attraction force decrease and the state of matter change. And also this happens in liquid state. When the liquid substance is heated, the molecules gain thermal energy. The speed of the molecules increase, and some of them overcome the intermolecular force. So the intermolecular spaces increase and they change into another state. So we can say that solids by heating can change into liquid, and this process is called melting. And also liquids by heating can change into gas, and this process is called vaporization. Melting is a change of matter from solid state into liquid state. Vaporization is a change of matter from liquid state into gaseous state. Then we will talk about the molecules, the structure of the molecules, and also we will talk about the kinds of molecules. As we said, that molecules are the building units of matter, and each matter consists of molecules. Let's take an example. If we're talking about water, this cup contains small amount of water. If we want to see, we will see that the cup contains molecules of water, and each one molecule consists of smaller building units, which is known as atom. So matter consists of molecules, and molecules consists of atoms. The cup of water or the water consists of molecules, and each one molecule consists of atoms. So the drop of water consists of or contains millions of water molecules, which can't be seen by naked eye. Also, the molecule of one substance is alike. If you see these, all these are molecules of water. They are similar, they are alike in the properties, but they are different from another substance molecule. For example, the water molecule is different from the table salt molecule. All the water molecules similar to each other, and they are different from the table salt molecules. And also we can say that the molecules consists of tiny structure called atoms. This is one molecule of water. Can you count with me how many atoms in this molecule? 1, 2, 3. Water molecule consists of 3 atoms. We can say that the difference in molecule of different substance is found as a result of why the molecules are different. They are different due to the difference in the number of atoms. For example, as we said that water molecules consists of 3 atoms. A table salt molecule consists of 2 atoms. So they different because the number of atom different. Also the kind of atom. Here if you see, water consists of 1 oxygen and 2 hydrogen. Another molecule like oxygen molecule consists of only oxygen atoms. The way of combination together. So we can say that molecules are different because the number of atom, or due to the difference in the number of atom, the kinds of atom, and the way of combination together. Can you see that the drop of water, as we said, consists of millions of water molecules that can't be seen by naked eye? Then we can say that the kinds of molecules are element, molecule, components, molecule, and mixture. In this lesson we will study the element and the compound. Let us start with the element molecule. What is the element? Element is the simplest pure form of matter, which can't be analyzed chemically into simpler form. For example, if we take an element like copper, we can say that copper is the simplest form of matter. Or sorry, it's the pure form of matter and simplest form of matter. And it can't be changed into more simple. It can't be analyzed or changed into simpler form. It is the simplest form. So element is the simplest pure form of matter which can't be analyzed. The element can't change into simpler form. And we can say also that element formed of similar atoms. Element formed of similar atoms. Element may be monoatomic molecule or monoatomic element. It consists of only one atom. The monoatomic element consists of only one atom. It may be solid like iron, sulfur, copper, and aluminium. So if you see, it's only one atom of iron, one atom of sulfur, one atom of copper, one atom of aluminium. Monoatomic means it consists only of one atom. Element is the simplest pure form. It can't be analyzed. The first type of element is monoatomic. The monoatomic element, it consists of only one atom. It may be solid like iron, sulfur, copper, aluminium, magnesium, carbon. It can also be liquid like mercury. Mercury is a liquid monoatomic element. And it can be gas like inert gases, argon, helium, krypton, xenon. So the inert gases are monoatomic gases. the inert gases are monoatomic gases. What about the diatomic element? Diatomic element means it consists of two atoms. Diatomic elements mean it consists of two atoms. Like, it may be it may be liquid or gas. Liquid like bromine. Bromine consists of two atoms of bromine. It may be gas like oxygen, nitrogen, and hydrogen. Look at oxygen, two oxygen atoms, hydrogen, two hydrogen atoms, nitrogen, two nitrogen atoms. So the diatomic molecules consists of two atoms, liquid like bromine, gas like oxygen, hydrogen, and nitrogen. They are active gases. And if you remember with me, the monoatomic gases were inert gases. So the molecules of active gases are diatomic, while the molecules of noble gases or inert gases are monoatomic. We can say also that mercury is the liquid element which is composed of one atom. Mercury is monoatomic liquid element, while bromine is diatomic liquid element. We talked about the simplest pure form of matter, which is element. And now we will talk about the compound. The compound formed of different atoms. It consists of two or more different atoms. So the compound is a substance which formed from the combination of atoms of two or more different elements. The combination of atoms of two or more different elements. For example, we have ammonia. Ammonia consists of different atoms, which is hydrogen and nitrogen. Ammonia consists of one nitrogen atom and three hydrogen atoms. If you see the element, it consists of oxygen, similar atoms, while compounds consist of different atoms, nitrogen and the three hydrogen, ammonia. Water consists of one oxygen atom and two hydrogen atom. Sodium chloride or table salt, it consists of one sodium atom and one chlorine atom. So elements consists of similar atoms, while compound consists of different atoms. Elements may be monoatomic or diatomic, like hydrogen, aluminium, sulfur. Compound like water, carbon dioxide, sodium chloride, calcium carbonate. We have many examples of compounds. We finished our lesson. See you in the next lesson. Thank you for listening.